Hello everyone, my name is Pranjal Jain. Welcome back to Hike. Today we are going to solve a question named Max Non-Negative Subarray. So I'll be explaining the question first, then we'll look at the different approaches, and then we'll even code them. So look at the entire video very carefully so that you can understand everything about this particular question, how to solve it, how to make the approach to solve it, because everything is equally important. So without wasting any more time, let's get started. So the name of the question is max non-negative subarray. Given an array of integers a of length n, find out the maximum subarray of non-negative numbers from A. The subarray should be contiguous, which is subarray created by choosing the second and the fourth element and skipping the third element is invalid. Maximum subarray is defined in terms of sum of the elements in the subarray. Find and return the required subarray. So if there is a tie, compare with segment's length and return the segment which has maximum length. If there is still a tie, return the segment with minimum starting index. All right, so let's take an example and try to understand this question. So let's take this particular example 125 minus 7 to 3. So the test case we are taking is 125 minus 7 to 3. Now, if you look at the subarrays that do not contain a negative number, this is one subarray that doesn't contain any negative number, and this is the other subarray. There is no other subarray possible without a negative number, of course. So to maximize the sum, we would like to take longest possible subarrays without a negative number. Otherwise, this is also a subarray, but there is no use considering it because we have a longer subarray with positive numbers. So of course, the length will decide the sum, the total sum. So we want to take the longer ones, right? Okay. So the sum of the first subarray that under consideration, this is the first one, this is the second one, is 1 plus 2, that is 3, 3 plus 5 is 8. Of the second one, it is 2 plus 3, 5. So we have to return this particular subarray as the answer, as this has the highest sum. How can we solve this particular question? So one of the ways is to enumerate all the possible subarrays, find out whether they have a negative number in them or not. And out of those subarrays which do not have a negative number in them, find the one with the maximum sum. But that will take a lot of time complexity. What we are going to do is we are going to use sliding window. We are going to use a sliding window here. So with this example, let us see how this sliding window is going to work. 1, 2, 5 minus 7 to 3. So we are going to put one of our pointers over here and the other pointer is going to start from here. This will keep moving forward and adding the numbers together until we see a negative number. So this will move forward. Still not a negative number. This will move forward once again. Still not a negative number. This will move forward once again. We are seeing a negative number now. So the valid window is only this much, right? So now we have the sum of this particular window and we will store it in a variable. We'll move forward. Now this first pointer will start from this position and will look for a positive number. So this is not a positive number. This is a positive number. Now we bring j to I, and now j will keep moving forward until it reaches the end of the array or it finds a negative number. So it moves here, then it moves here. Now j has come to the end of the array. So this is the valid window. We get the sum of this window, and whichever has the maximum sum, that is going to be returned. So this is the approach that we are going to use. We're going to use the sliding window concept to reduce the time complexity to O of, and we are going to use O of 1 extra space. Now let us have a look at how to code this particular question. Along with coding the questions, I'll be telling you a few corner test cases that we have to take care of. Let's get started. So first of all, we will have to take a few variables. Let's take them. Current sum will hold the sum of the current window under consideration. Current start will hold the index of the current window under consideration. Current end will hold the current end, the end point of the current window under consideration. Sum will hold the global maxima we have seen so far. Start will hold the start position of the global maxima we have seen so far. And end will hold the end position of the global maxima we have seen so far. Now, let's get started. Let's take a pointer P1. It started from the 0th index. Now, while P1 is less than A dot size, we're going to run this particular loop. Now, if the pointer P1, A of P1 is greater than 0, greater than equal to 0, so now what do we have to do? We have to place the start position over here. Start of the current window is going to be P1 now. So current start, we are making it equal to P1. Now, while P1 is less than A dot size, that means P1 doesn't get out of bound, and A of P1 is greater than equal to 0. So while A of P1 is positive and P1 stays within the possible indices, what do? In current sum, we add the value of A of P1. Before starting this loop, we'll make current sum equal to 0. And inside this, we'll keep incrementing the value of P1. Now, there will come a point where either P1 will get out of bound or A of Pi or A of P1 will become negative. Okay, so what do? We make current end equal to P1 minus 1. Now we have a valid window from current start to current end, and its sum is stored in current sum. Now we will compare it to the global maximas. If current sum is greater than sum, then there is no confusion. This window contains the global maxima. We'll make start equal to current start, and we will make end equal to current end. And we will update the value of sum as well to current sum. Now, if the sum is same, if current sum is equal to sum, now this is the case that was given in the notes. If there is a tie, we have to compare the segment's length. Okay. If there is a tie, we have to compare the lengths, and minus start is less than current end minus current start. If this new segment is longer than the previous segment, but they both have the same sum, we have to return the segment with that is longer, right? So that is what we have compared over here. We'll update the value of start as current start, and we'll update the value of end as current end. That's it. Otherwise, if it is not, if A of P1 is not a positive number, otherwise we'll just increase the value of P1, right? So by the time this entire loop ends, we will have the maximum value, maximum sum in sum. We'll have the start point in start and the end point in end. So we have to return the vector that particular subarray. So we'll create a vector of integers answer. Now we'll run a loop for int I equal to, so it's going to run from start to end, and we're going to add all the numbers into answer. And finally, we are going to return the answer. But there is one thing that we need to check. In case there is no window that has a positive number, all the numbers in the array are negative. What do? We have to check that if start is still equal to -1, that means there is no window that has a positive number. There is no valid window. So we return the empty vector answer. This is it. This is how we have coded. Let us try to run this and see whether we are able to solve the test cases or not. So we are able to solve the visible test cases. Let us try to submit this now. So as you can see over here, we have failed a test case. Let us try to understand why we failed this test case. There are integers in this particular array, but when we add multiple integers, they can go out of bound, right? Out of bound of the range of possible integers, right? They can be greater than int max. So to handle that case, we will make the data type long int for current sum and sum. Now let us again try to run this. So this is one thing that you have to take care of. We have integers, definitely, but if we add them or multiply them, then they can definitely go out of bound. So if you're adding integers or you're multiplying them, always remember to take long or long int. So as you can see over here, we're able to pass all the test cases now. So that was it. Thank you so much for watching. And I really hope you guys understood what I was trying to explain. And if there is any doubt whatsoever, please feel free to comment it down below and I'll be more than happy to solve any of your doubts. Thank you so much, guys. I'll see you in the next video. Have a great day.